Welcome to Chapter 2, Lesson 5, where we will be solving multi-step equations. With each of our lessons since the beginning, we have been building on top of our skills of solving equations. We started at Lesson 1 with our foundational skills, and now we're moving into the final lesson. We're going to be adding in our last and final steps. We're also going to talk about multiple different types of solutions that we could get. You'll see that on an upcoming slide. Let's start with the vocabulary. First, we have the null set, which is when an equation has no solution. Null set just simply means out of all the set of numbers, nothing we plug into the equation will ever make the left side and the right side equal, which, as we know, with every solution we've ever gotten, if we check our work by plugging in the answer we got for the variable, the left should equal the right. Well, we're going to talk today about some cases where that's not true. The next piece is the identity, which is when an equation has every value as true. And what that means is for the left and the right, they will be equal no matter what number we choose. So if we're going to check see whether an equation is true, as in the left and right are equal, we could select any number out of all the real numbers, and the equation would still be true. So far, we've only dealt when there is only one possible number, but we're going to build into these other two types of solutions. Before we do that, let's start by adding in the last pieces for solving these equations. For solving our algebra equations, we would start at the distributive property. We see we have these parentheses, which means we have to take the 15 and multiply it to the 20, then multiply it to the d. So it's multiplying. We know 15 times 20 would be 300. 15 times d is a positive 15d, and that equals 420. So step 1 complete. Next, let's move all the letters to one side. The great thing about this equation is there is only one term with a letter, the 15d, so it's already on one side. And now we'll look at the last step, which is to move all numbers to the other side. Well, since we have the 15d over on the left, we also have the 300. So I need to remove the 300. It's positive, so I'm going to subtract. On the left, that becomes 0, and I bring down my positive 15d equals 120. And for us to truly finish this problem, we must now divide or multiply to get rid of our coefficient. Well, since it's 15 times d, I'll divide by 15, and find that d equals 8. So for this example, the only thing that was new was this distributive property. Next, let's talk about our types of solutions. So far, we are familiar with the one solution. Every problem you have solved has had only one answer. It is when the variable equals the number at the end. But we have two other types. We have no solution, which if you notice in no solution, there is no variable, there is no x, there is no letter. We have a number on the left and the number on the right, and they are not equal to each other, which means in that equation, there is no number at all in the real number system that I can put in for whatever variable was there to get an answer. Over on the right, we have the identity, which is also commonly known as all solutions. We see that the variable has disappeared, and I'm left where the left side says 2, and the right side says 2, and we know that 2 equals 2, so it is true. And 2 equals 2 is what we would call an identity. Let's take a look at two more examples where we're going to actively see what happens when the variable cancels itself out and disappears. I'm going to go ahead and start with step 1 to distribute. And I'm just going to do it all at once. So I'm going to look at the 6 times the x, 6 times the minus 3 to get 6x minus 18. I'm going to go ahead and bring down my 10. And that equals, well, I got to do 2 times 3x, which is 6x, and 2 times minus 4, which is negative 8. Next up, I should go ahead and combine like terms. If you notice over on the left, I have this minus 18 and this plus 10. Now I am marking them to show that they are like terms, and I'm going to go ahead and combine them by adding. Negative 18 plus 10 leaves me with a negative 8. And then I'll go ahead and bring down my 6x equals, and then copy down the right side. I want you to notice one thing right now. Take a look at this line in the problem. The left side and the right side say the exact same thing. And I want you to make just kind of a guess at what you think is going to happen when I continue the problem. What kind of an answer am I going to get since I have the left and the right side equaling each other and saying the exact same thing? The next step we would try to do in solving this would be to move all the variables together, and I'm going to do that by subtracting 6x. It's going to take this x here, and I'm going to move it to the left side by subtracting it. But let's see what happens. Minus 6x would mean I have now a 0x on the left. So this is canceled out. I get minus 8 equals minus 8. So I asked you before to take a guess at what's going to happen in this answer. And what we see is when the x's are canceled out, I'm left with negative 8 equals negative 8. Well, when a number equals itself, we call that an identity. And you also hear that many times called all solutions. Let's take a look at our next one. I have, again, the same first step. I see parentheses. I should distribute. So the 8 multiplies to the 4, 32. 8 multiplies to the minus 2x for negative 16x equals, I gotta do 4 times 3, which is 12. 4 times negative 5x, which is negative 20x, plus 4x. I'm gonna bring down that last piece. Second, I should go ahead and combine my like terms. On the left, I don't have any like terms, but on the right, I have this minus 20x and this plus 4x. I'll go ahead and add those together. So now the left side will say 12 minus 16x. On the left is 32 minus 16x. And I want you to make an observation. Like on the previous problem, when you look at this line here, they both have a minus 16x. So they almost match each other, except when it comes to the constants, the 32 and the 12, those are not equal to each other. So even though they're almost the same, they are different. When I go into the next step, which will be to get all the variables to one side, let me go ahead and add 16x to move, we'll say, the one on the right over to the left. So I add 16x, I add 16x. Like before, these end up canceling each other out, and I'm left with 32 equals 12. Now, that should sound strange. 32 equals 12. Well, we know that 32 does not, in fact, equal 12. So this is an answer where we get the null set or no solution.